Today we started part 2 of Unit 7, which is on logarithmic functions. Logarithmic functions are inverses of exponential functions. In other words, the two functions undo each other. Logarithms can be very helpful if we're solving a problem like this. 2 to the what power equals 6. We know that's not going to come out evenly. So to be able to solve for that decimal, we can use a log problem because logs can be used to solve for exponents. If you look in the key concept box, it says let b and y be positive numbers with b not equal to 1. The logarithm of y with base b is denoted like this, okay? And that expression is read as log base b of y. Log base b of y is equal to x if and only if b to the x equals y. Now first thing, in math, that phrase if and only if implies that this is true in either direction, no matter what way you read it, that's true. What that means is I can use this and convert it to exponential form, or I can start in exponential form and convert to log form. Now a couple of things. You'll notice that the log base is also the exponential base. Another thing, the answer to a log problem is the exponent in the exponential function. That's why we use logs. We're using logs to help us solve for that exponent. Now, a lot of what we're going to do this first day is look at rewriting from one form to the next. So if you come down here in this first example, it asks you to rewrite the logarithmic equation in exponential form. And we have log base 3 of 81 equals 4. Well, what you might want to start by doing is labeling the parts you have and realize we're trying to fill it into this form. Just put the parts in the place they need to go. Your log base will be your exponential base. The answer to the log problem is your exponent. And then 81 is the answer. When you're rewriting, you should end up with a true statement. And if you check, 3 to the 4th is equal to 81. Okay? Log base 7 of 7 equals 1 can be rewritten as 7 to the 1st equals 7, which is a true statement. Let's do one more. Example C, log base 14 of 1 equals 0. Well, in exponential, that would be 14 to the 0 power equals 1, which is also true because we know anything to the 0 power equals 1. Now, if you look at example D, this one's a little different. This one says log base 1/2 of 32 equals negative 5. In exponential form, that would be 1/2 to the negative 5th power equals 32. Well, if you look at what you have, remember a negative exponent just means the reciprocal of, okay? Well, the reciprocal of 1/2 would be 2, and 2 to the positive 5th power would be 32. We can also use the same rule and go in the other direction. If you look at this next section, it says rewrite exponential equations in logarithmic form. Well, this is in the form b to the x equals y. And so for the log form, it's log base b of y equals x, all right? So for this problem, it will be log base 3 of 81 equals 4. Let's skip example B. Example C will be log base 2 of 1024 equals 10. Remember, the log problem should always be equal to the exponent. Now we can use the same rule and actually help ourselves solve for the exponent. Sometimes it's a little hard to find the answer without using a calculator just by looking at it in log form because we're not quite as familiar with it in log form. Okay? If you set this up saying that I know a log problem will be equal to the exponent and convert to exponential form, sometimes it's easier to see the answer. If I took this problem and wrote it in exponential form, that would be 15 to the x equals 15. Well, the only exponent that doesn't change the value is x equals 1. Another example, if you look at this one, this would be 7 to the x equals 49. And then you just have to ask yourself, well, 7 to what power makes 49? Well, we know that that's when your exponent is a 2. Now, if you look at example C, you might need to think about a little bit. This would be 3 to the x equals 1 over 27. Okay? Now, one thing you need to think about is what type of exponent would cause something to flip or be the reciprocal. And hopefully you recognize that that would be a negative exponent. Whenever you go from a whole number to a fraction or a fraction to a whole number, that's because your exponent should be negative. So what you have to think about is 3 to what power makes 27, and that would be 3. And so to make 27 and do the reciprocal, your exponent would have to be to the negative third power. Now, a couple of things where there's a couple of special cases, if you come down here where it says special logarithms, that you actually can evaluate on the calculator, okay? It says a common log is a logarithm with base 10. It is denoted by log base 10 or simply by log. So on the calculator, you have a log button, okay? When you see that log button, or if you just see the word log, you can assume that your base is a 10. Those you can do on the calculator. We also have a natural logarithm. This is when your log base is an e. You can write log base e, but the way you're going to see that the most often is ln, or natural log. If you look on either the scientific or the graphing calculators, it doesn't matter. Here is your log key, and here is your natural log key. Anything that uses those two special logs, you can just evaluate on the calculator. For example, this one says find the log of 5. If you don't see a log base, you can assume it's a 10. So this I'm just going to type in log of 5 and then close my parentheses. And so the approximate value, it says to round to 3 decimal places, is about 0.699. Natural log works the same way. Natural log just means you have a base of e. Just hit natural log of 8, and it's about 2.079. We'll skip example C, it's very similar. If you look down here, even with fractions, as long as you close the parentheses, it doesn't make any difference. This one I'll just type in natural log of 1 divided by 3, close my parentheses, and this gives me a value of about 1.099. Now, it's really nice to be able to use the calculator on problems, but you can only use the calculator if you have a base of 10 or a base of e. So there is a way that we can evaluate any log using your calculator. You just have to know how to type it in. It's called the change of base formula. What this allows you to do is to change to a base 10. What you do is if you have something in the form log base c of a, you take the log of a divided by the log of c, and that will do this for you on the calculator. You can't actually type in a subscript or a log base other than 10 or e on the calculator. Natural log is the same way. You can do those problems the same way. So if you look down here, it's log base 5 of 8. I can't put base 5 into the calculator, so to change that to base 10, I am going to type this in as log of 8. Make sure you close the parentheses after the 8, divided by log of 5, and this will evaluate it for me. Okay, so log of 8, close the parentheses, divided by log of 5, gives me a value of approximately 1.292. Okay. Log base 8 of 14, I can evaluate by typing log of 14 divided by log of 8. You get approximately 1.269. So that's a way that we can evaluate any log on the calculator.